Okay, welcome to your Kin 225 class for Wednesday, February 24th. Here are some announcements. Just a reminder that there's no lab next week because your midterm exam is next week on Wednesday, March 3rd. I will try to do a review for you on this Friday for the in-person class. So the midterm exam, you can see, is 50 multiple choice questions worth 1 mark each. 5 short answer questions worth 2 marks each, covers material up to and including today's class. So that should say up to and including today's class. You will have 48 hours to write the exam, so it's a take-home exam, and you will send me your answers by email. And your final exam is set for Monday, April 26th. It's a take-home exam, and you'll have 48 hours to do that. If you have any questions about material, you can always email me at phil.chilovec@usask.ca. So for today's class, we're going to be reviewing the bilateral deficit, the Golgi tendon, organ, and the muscle spindle. So I have some multiple choice questions for you on those. The topics for today include cross education, which is another neural phenomenon that occurs when you're training. And then briefly cover an overview of nervous system anatomy, and then how that applies to rehabilitation from spinal cord injury and types of movements, so voluntary, reflexive, and rhythmic movements. So some review questions for you here. The bilateral deficit occurs if the amount of weight you can lift using one limb is greater than 50% of the weight you can lift with 2 limbs simultaneously. The answer to this is true. So logically, you'd expect that the amount of weight you can lift with one limb is about half of what you could lift with 2 limbs, but often it is more than half. So you're actually weaker. Your limbs are actually weaker when they're contracting simultaneously or bilaterally, and that's called the bilateral deficit. So the answer to this is true. You seem to be weaker if you're contracting your limbs together bilaterally as opposed to contracting them unilaterally or one at a time. Which of the following would enhance force development? So activation of agonist muscles, inhibition of antagonist muscles, inhibition of the Golgi tendon organ, or all of the above? The answer here is all of the above. The Golgi tendon organ inhibits your agonist muscles and activates your antagonists, so you'd want to inhibit that to get maximal force development. Activation of the muscle spindle in the hamstrings will excite the motor neuron innervating the hamstrings, inhibit the motor neuron innervating the quadriceps, or all the above. The answer here is all of the above. So the muscle spindle will send excitation to the spinal cord to activate the motor neuron of the muscle that the muscle spindle is located in, and then it sends inhibition to the motor neuron of the antagonistic muscle group. Activation of the Golgi tendon organ in the quadriceps will excite the motor neuron innervating the hamstrings, inhibit the motor neuron innervating the quadriceps, or all of the above. The answer here is all of the above. So when the Golgi tendon organ is activated, it sends inhibitory input to the spinal cord to inhibit the motor neuron that innervates the muscle that contains the Golgi tendon organ. So in this case, it's the quadriceps. So you get inhibition of the quadriceps. And then it sends excitation to the antagonistic muscle group. In this case, it's the hamstrings. So it excites or activates the hamstrings. First topic for today is this neurophenomena called cross-education. So it's defined as the increase in strength of the untrained contralateral limb after unilateral training. So what does that mean? The contralateral limb is just the opposite limb of the same type. So in this case, with this girl that's training here, she's training her right arm with a hand grip device. The contralateral limb would be her left arm. So cross education occurs when you're training one limb over a period of time, say several weeks, and you'll actually get a crossover of strength increase in the opposite limb, even though this opposite contralateral limb has not trained. And this is caused by altered nervous system activation. So it's thought to occur from transfer uh, of training from one side of the brain to the other. So this this diagram illustrates the concept of cross education. So in this case, the person's training just with their right arm, say over weeks or months. And you can see the green, the left side of the brain controls the right arm. The yellow, or the right side of the brain, controls the left arm. With unilateral training, so this person's just training their right arm, you get activation of the left side of the brain, but you get some crossover to the right side of the brain so that the untrained arm actually increases in strength. And the amount of strength increase you see in that untrained arm is about half, or about 52% of the trained limb. So if the trained limb, say, increased in strength by 100 pounds, the untrained limb would increase in strength by about 50 pounds. So the magnitude of the cross education is related to the strength increase of the trained muscle. It's about half in the untrained limb. And this phenomenon is greater if you have a more novel, unfamiliar task.